Okay, so for number 9, we want to prove that if A is contained in B, and B is contained in C, and C is contained in A, then A is equal to B, and B is equal to C, right? So the first thing that we are going to prove is we're going to prove that A is equal to B. So for us to prove that A is equal to B, we have to prove a double inclusion. We have to show that A is a subset of B, and B is a subset of A. If we show a double inclusion, we have shown that this means that A is equal to B. So let's first show that one. So we're going to say, let A, B, C be any sets, and let A be a subset of B, B be a subset of C, and C is a subset of A. So we're just supposing that A is in B, B is in C, and C is in A, right? So our first mission is going to show that B is contained in A. So we're going to say let X be any element in B. Note that B is a subset of C, so X belongs to C, right? So X belongs to C. Because that's what it means for B to be a subset of C. And now we want to show that that element in B is also in A. So note that C is a subset of A. So X belongs to A, right? And we have that X belonging to B implies X belongs to A, so B is a subset of A. We have that A is a subset of B because we assumed that A was a subset of B, right? And we just showed that B is a subset of A. And remember that we showed this because we showed that any element in B must also be in A. And so thus A is equal to B. So we've shown the first part because we've shown a double inclusion. And now we want to show that B is equal to C. So we want to show that B is contained in C and C is contained in B. We want to show a double inclusion. So we're going to say let Y be any element. Oops, let me rewrite this. Be any element in C. All right. And what we want to do here is show that that element must be in B. So note that C is a subset of A, so Y belongs to A. And then note that A is a subset of B, so Y belongs to B. We're showing that, hey, if it's in C, it must be in A, and if it's in A, it must be in B. And so we have that Y belongs to C implies that Y belongs to B, so C is a subset of B. So C is a subset of B. And remember that we assumed that B was a subset of C, right? We assumed this. So we're going to say we have that B is a subset of C, and we just showed that C is a subset of B, so C is equal to B. And we've shown that by a double inclusion. So that is it for item 9. We have proved the theorem. We have shown through double inclusion that A is a subset of B and B is a subset of A, so A is equal to B. And we have shown that B is a subset of C and C is a subset of B, so C is equal to B. And that is it for item 9.